All right, this is the homework, worksheet number 6, test review. We're going to do 1 through 3, which are the identities. So on this one, right away I noticed that I'm adding fractions, and the nice thing is my denominators are factors of difference of squares. So that's going to work out really nicely. So I'm going to get a common denominator. My common denominator is going to be that difference of squares, which is 1 minus cosine squared x. So this fraction is missing the 1 plus cosine x, so I'm going to multiply sine x times 1 plus cosine x. This one is missing the 1 minus cosine x. So sine times 1 minus cosine x. And on the bottom, I get 1 minus cosine squared x. Now, recognize we're trying to get to cosecant, which is the reciprocal of sine. So it's probably going to be helpful to change this, my Pythagorean identity, to sine squared. So meanwhile, on the top, what I notice here is everything is going to have a sign in common. So I could multiply this out first and get sine x plus sine cosine x plus sine x plus sine cosine x, but recognize every single one of these has a sign. So I can pull out a sign and then leave this stuff. So I have 1 plus cosine x plus 1 minus cosine x. And again, that's because everything on the top has a sign in common. And on the bottom, we're changing it to sine squared, which is our Pythagorean identity. Now I can cancel this sign with one of these. Cosine x minus cosine x is gone. And on the top, I'm left with 2. And on the bottom, I'm left with sine x, which is 2 cosecant x, which is what I wanted to get. All right, number 2, same thing. I'm adding some fractions. Need to find the common denominator. This fraction is missing cotangent, so I'm going to multiply it, which gives me cotangent squared x. This one is missing the 1 plus cosecant. Again, this is squaring a term. So square the first, multiply these two together, which gives you cosecant x, and then it's 2 of the middle, and then square the last. So cosecant squared x. On the bottom, I have 1 plus cosecant x times cotangent x. Again, keep them as multiplication. They are easier to cancel. And now on the top, I want to get everything in terms of secant. What I notice is I have cotangent and cosecant. So let's get rid of this cotangent up here by replacing it with what it equals. It's a Pythagorean identity. So if you look at your sheet, the actual whole thing here, cotangent squared, is cosecant squared minus 1. So we're going to replace it with cosecant squared x minus 1. So this cotangent squared became this. And then I still have plus 1 plus 2 cosecant x plus cosecant squared x on the top, and 1 plus cosecant x cotangent x on the bottom. So now what I see is I have a negative 1 and a positive 1, so those are gone. And on the top, when I combine like terms, I have 2 cosecant squared x's. So I'm going to combine those, and then I still have this plus 2 cosecant x on the top. On the bottom, I have 1 plus cosecant x times cotangent x. I can see that both terms here have a 2 in common. So I can pull, and they also have a cosecant. They have a 2 and they have a cosecant. So my greatest common factor is 2 cosecant x, which leaves me with cosecant x plus 1. On the bottom, I still have 1 plus cosecant x, cotangent x. These two can cancel. Addition is commutative. Order doesn't matter. So those are gone. And now I want to look at what I want to end up. I want to end up in secant. So I'm going to change everything to sine and cosine for now. So I have 2 over sine x divided by cotangent, which is the same thing as multiplying by tangent. So multiplying by sine x over cosine x. This cancels with this. I'm left with 2 over cosine x, which is 2 secant x, which is what I want to end up with. All right, last identity on this page, I have number 3. So again, on this one, I'm not adding fractions. I have a fraction. What I do notice is that this is a Pythagorean identity that involves cosecant, so that might be helpful to put in there. So cotangent squared is the same thing as cosecant squared x minus 1. So I replaced this with this, and then I have 1 plus cosecant x. The nice thing about a lot of Pythagorean identities is they are difference of squares. So this one is cosecant x plus 1, cosecant x minus 1 over 1 plus cosecant x. Again, addition is commutative, order doesn't matter, those two cancel, and I get cosecant x minus 1, which is what I wanted to get.